How's everyone doing? So I would like to first have our esteemed panelists introduce themselves. If you guys want to just start with a quick introduction about who you are, what you do, what you're focused on, and then we can kick it off.
I'm Jay Rogers. I run Local Motors, and we do co-creation and rapid manufacturing of vehicles.
Hey everyone, I'm Arjun Agarwal, an associate with New Enterprise Associates. Spent a lot of time looking broadly at the enterprise software landscape, and more recently spending quite a bit of time around industrial manufacturing technology.
I'm Karen Carr. I'm Executive Director at GE Ventures, and I lead a team that focuses on investments in advanced manufacturing and enterprise software. So my team is very much focused on technologies that help GE to be a better enterprise, and most of that is around how we run our manufacturing operations better.
Great. So, as you all know, we're going to talk about how 3D printing is changing the broader landscape. Why don't we start by talking about what are the recent sort of advances in 3D printing technology, and how have they been applied commercially?
Well, I'm happy to go,
on
that one, because many of you know that that GE itself has gotten into the additive game, purchasing two companies, Arcam and Concept Lasers. Actually, we own a majority share of Arcam. Both are powder bed technologies. One is an electron beam, and one is laser sintering. But what we have found, and the reason we purchased these two companies, is because we were using their technologies to help us make parts for our jet engines. So we started off with a fuel nozzle, and what we're finding is that the quality of the machines has improved, the materials has improved, and so the quality of the products that you can make have improved. And we're able to make this, to get real value by taking complex parts that are really hard to braze a lot of small components together and make them in a single build. And that's how we've sort of found some value there by unlocking the design engineering.
I think from our perspective, there's kind of a couple of different parts of the equation. There's speed of printing, resolution of printing, and the materials that you can print with. And we've seen kind of in the last decade or so dramatic improvements across the board in all three. And I think that those have been really what's brought 3D printing out of just kind of the hobbyist realm and really into the mainstream across the production floor even.
Plenty of examples of industries that have been bubbling for a long time. Electric car industry was bubbling for 120 years until it got to a stage where there's this amount of interest in it. 3D printing, I would say, is very much the same way, younger, 25 years in development, and I think this year represents a watershed moment, but there are spikes that have come along. So, you know, Karen and Arjun have represented some spikes. We are particularly interested in the spike in large-scale polymer because of the deposition rates. We care less about surface finish and for our use case, so that makes that spike at interest. So specifically this year, we're seeing deposition rates now in printing at 80 pounds an hour, which means if you're building a structure that's 800 pounds, that means it's going to take you 10 hours to print. So that sort of gives you an idea. That is a watershed moment for us, because it means that at the size, scale, and volume with a structural part that you need to print, we have gotten that kind of size and reliability. What's not there is the software side yet to be able to predict what it is that you need to make from a stress perspective, or taking a what you'd call a nominal CAD model and put it into an as printed and as manufactured. So that needs to come along on the enterprise software level. My prediction is we've seen the first additive suites come out from the major players and some of the minor players this year, and we're going to see that enterprise software really come along, because the egg is there, which is the printers. Now the chicken needs to come along a little bit, and I think that this year, our hope this year is that that will make itself known in large-scale polymer. Large-scale metal also is something that we haven't talked about, but wire-fed metal is coming along now at deposition rates of 3 pounds an hour in an energy-efficient way for open-air iron printing. There are other more performance materials too that I think are great, and so we've seen the first large-scale pieces without surface variety that have been printed. So if you're watching an industry and the downstream effects of, say, for us as a manufacturer, what it means, this year is a big one.
So what kind of, within a specific manufacturing industry, let's say, how will 3D printing change the workflow, change the processes? Walk through an example of that, where, excuse me, where the 3D printer could insert itself and where are the traditional processes, will there still be in place?
I'll start on that one if I can. So for making a vehicle, we could have started in any industry, and in many ways we do use 3D printing in our other industries for co-creation work. For a car, it's a highly complex cyber-mechanical device. It's large. And so if we're talking about that, large-scale polymer makes a big difference because we don't have a tax of tooling time. So one thing that is often discounted is how long it takes to integrate technology into a vehicle. Take, for example, the electrification of a vehicle or the onboarding of sensors for autonomy. These are pieces of technology that are in rapid change right now. Looking at the sensor industry alone, going from dynamic LiDAR to solid-state LiDAR is a change in form factor, energy intensity, mean time between failure. All that means is that the stuff you put on your product is changing quickly. But the way we make that product traditionally changes very slowly. And so adding in large-scale additive into it allows the vehicle structure to keep pace with the change of technology. If you want to be right on the market at the time where the product's coming out, that shows a clear use case for additive in this case. Has to be reliable, has to be robust, and in our opinion, has to be more than just prototype volumes, which is why this year is an exciting time for us.
I think, Jay has spoken to automotive really well. I think broadly across industries, we're at almost a little bit of a tipping point where historically we've seen prototyping being where 3D printing has kind of had its primary application. We're now seeing technologies that are really enabling low volume, short run products really start to be disrupted. So you see a lot of industries like medical, dental, jewelry, where you have these intricate pieces that are not necessarily high volume, but need to be customized. And I think you see processes around that changing as they start to use 3D printing more often. I think you see broadly aftermarket processes changing. So dealing with supply chain, instead of taking your BMW into the shop and them saying, oh my God, you have to wait like 3 months to get your part shipped from God knows where, they'll be able to on site ostensibly print up a new part to repair the vehicle. And so that's kind of where we're at now, and I think we're slowly starting to see technologies emerge that are going to bring 3D printing into a mass production realm. And that, I think, is where we're going to totally see the manufacturing process upended, as we have printers that can now take the place of very standard casting or machining applications.
Yeah, we really started off in an effort to try to replace some of our casting and some of our tooling originally. What we have found, and to go back to a point that Jay has made on the design software, that we've actually been able to radically reduce part counts. And that's going to profoundly impact the supply chain as well, because I just need fewer suppliers, because there are fewer things that I need to assemble. Just as you're doing with your automobile, we're doing that with our jet engines and now with some of our turbines on the energy side. But I'd agree with Arjun that we're certainly starting to see the speeds increase. And we're both investors in Carbon, which has a clip technology, polymer-based, 100 times faster than most of these machines. They've just announced that they're printing shoes for Adidas. And so now you're seeing it go into mass production. And we're seeing some similar technology starting to emerge on the metal side as well. We're in desktop metals.
Yep.
And then I've certainly seen some technologies coming out of Lawrence Livermore that are trying to do something similar to Carbon, but with metals.
So to that point, in terms of the suppliers and looking how the supplier base is going to change, you were saying it seems like you're starting to bring some of that production in-house or some of the parts in-house. What is that supplier landscape is going to look like in the future with the advent of 3D printing?
I suspect we're all interested in how to shorten our supply chains, but I don't think our supply chains are going to go away totally. So one thing that I do think has to happen is that these types of technologies need to be accessible to small and medium enterprises that actually form the backbone of our supply chain. And so you're starting to see, you know, the typical machine might cost $500,000, $1 million, but you're starting to see machines with real capability come down to price points that are sub 100K, and you're seeing business models evolve such that it's not you buy the machine, maybe you rent the machine, and I think that's going to enable some of the mom and pop machine shops to get into the additive game.
I think the other thing with the supply chain is one of the primary reasons for utilizing additive manufacturing technologies is really to increase flexibility. And so you're not necessarily going to see, you know, a massive run of products where you have all this time to plan on the supply chain end. You're going to have a lot more flexible production, more just-in-time production, and that may require greater flexibility with suppliers themselves. And so I think there will likely be a gap that needs to be filled around integrating with suppliers, whether it's via software, you know, that will enable greater flexibility, higher transparency and visibility, and speed of acquiring the actual materials you need to, whether it's 3D print or machine, et cetera.
And those technical gaps you're talking about, those challenges that still remain, whether it's enterprise software, whether it's even more improvement in the machines themselves or the prices coming down, you know, what role do startups play in tackling those technical challenges versus what role does, you know, a GE, for instance, play in tackling those challenges?
I think here there be dragons. And so when you look at this marketplace as a startup and you're looking for how you're going to play, I'll just throw some things out for the field. We've had some incredible entrepreneurs. Look at Mitch Free, who started MFG.com, one of the best marketplaces for getting quotes at the low end of CAD work. Started a company with UPS to be able to develop off of basically a Stratasys technology. And good idea, great delivery, meaning you could get your part from UPS almost anywhere in the world, but you had to order it out of Ultem. And you had to order it in a specific size, which were made by specialty Stratasys machines that were being iterated very quickly. So here you have a supplier that built a whole business with a delivery system, and that is still in question as to whether there's enough customers there that understand how to order and can get it. So if you're in the business of being an entrepreneur, you can be in so many businesses, but you have to really detail the market. I think up on this stage together, you've got three people that know we see each other a lot,
Yeah.
and we see there's an ecosystem of maybe 100 other players that are probably deserve to be around and be on stage, and there are tons of winners. So the big blue arrow is it's going in this direction, and that direction is up. There are stories of where you can get lost on the way in materials and software, in machine making and other things, and so you have to be ready to ride the bucking bronco. But the big blue arrow is up.
I think that's fair, but I think there are sort of 2 points to that. One are the entrepreneurs and small businesses play a huge role, right? They're innovating on the models, quite frankly. I mean, that's what Mitch was doing. And in fact, he partnered with 2 large companies to try to do it. Now, I've followed that story a little bit, and the story has evolved some, because now they're partnering more with groups like Carbon and Desktop Metal, so they have more flexibility in the materials, and we'll see how that story emerges. The name of that company is Fast Radius, and it's a pretty cool concept. But I think it's a yes and. It's what we're doing at GE Ventures is we're keeping an eye out on that startup ecosystem so that we can help bring those innovations back to GE to leverage, and we think that's going to be a win-win for GE, for the industry, for the startup companies.
It's definitely a yes and. I think one of the things that we are, as investors, acutely aware of is for startups how difficult it can be to penetrate some of these large manufacturers. Sales cycles are long. It's difficult to find the right target persona. So while I think you're seeing huge amounts of innovation, all along the manufacturing process, whether it's supply chain, manufacturing itself, or logistics and delivery, I think that entrepreneurs and startups have to be very, very acutely aware of the challenges associated with selling into these types of companies. And that might require a change in the delivery of a product or a change in the business model and who they target it into, but definitely something to keep aware of.
And so for startups who are in this space, when they're looking towards sort of their bigger growth opportunity, how should they think about what their sort of end strategy should be, whether it's an acquisition by a large manufacturer, whether it's trying to stand on their own, and which, obviously the path to stand on their own is a lot harder, but what are the additional challenges they have to face being in 3D printing, being in additive manufacturing, and working with those challenges you just highlighted?
I would say that entrepreneurs have to be collaborative, for sure. This is not a time to keep secrets, so to speak, on most of the things that you do in your business. Because it's developing quickly, you need to stay in the know. It's a highly collaborative space, and so that means that you can learn, and what you are doing in your business today or who your customer is today may be different. Karen gave a great example at how fast Radius has evolved. I by no means think that Mitch is not on the track to success, but being collaborative and changing means that he could change a machine provider, change other things, a software provider. I mean, I'll give you an example for us is that there is every enterprise software business in the world that wants to play in the additive spectrum of part to production. There are startups that can play in that space, and then there are big companies that can play in that space, and then there are startups within big companies that can spin out and play in that space. But you have to stay collaborative to learn, because within a year, things are changing so much.
I mean, I'm happy to comment on this, how to work with the enterprise customer. And Arjun is right. I mean, we're not a monolith. It's difficult to sell to. But usually when you penetrate it, the contract values can be high and they can last a long time. So there's value to at least trying to do a little bit of elephant hunting. I always counsel companies to build a company that can stand on its own. And I'm investing in them, and part of my job is to help them penetrate GE. I have people on my staff just to help do that. But I always caution, don't just set yourself up to get acquired by GE, because you never know how that's going to turn out. And to be honest, I mean, sometimes we have an energy group, they've invested in companies, GE has done business with them, largest customer, and then we went out and bought a competitor. So you never know what's going to happen, but you should leverage some optionality and always try to be able to stand on your own.
Yeah, I would agree with that. And when we look at companies, if it's clear to us that they're just targeting an acquisition, that almost puts an artificial cap on the value that can be created, with the exception of some very large M&A transactions. I think there's a cap, and I think that companies should go out and try to stand on their own and build something great, but be collaborative and be open.
From the investment perspective, how much capital do these startups require at a minimum, say, in order to have the ability to build a business, to build the machines, to start selling it, and is it higher than, say, a traditional software company? And if so, then how do they sort of deal with those additional sort of capital challenges?
It's kind of funny. I think there's this notion that software is capital efficient, but software to scale takes a lot of money in the advertising, a lot of these sort of SaaS models. Whereas it takes more in the beginning on the hardware and the hardware iteration. But again, if you're selling to enterprise manufacturing customers, the go-to-market, I think, is a little bit more efficient, even though the sales cycle is longer.
Yeah, it's a little bit of a trade-off. I totally agree with what Karen just said. I think when you call SaaS capital efficient, it's because you have an initial investment in the technology, which in theory can be leveraged, but it requires a lot of capital to actually make those sales. And the reverse is true if you're manufacturing hardware. Some of that can be decreased by contract manufacturing, et cetera, but I think neither is tremendously more capital intensive than the other.
And this may be more of a question for Jay, but is there sort of any resistance from traditional manufacturers or traditional, suppliers around 3D manufacturing technology as a whole? Or sorry, 3D printing as a whole?
Is there resistance? Is that
Right.
your question?
Is there resistance? When a disruptive technology comes to the market, a lot of times with incumbents, there tends to be a little bit of tension. There tends to be a little bit of resistance. I'm wondering if that's the case in 3D printing at all, and if that's been a challenge at all.
Honestly, no. That may sound colossally different than what you would expect, but every supplier we meet is interested, from electronic suppliers like Bose down to ERP providers like SAP, and then to suppliers of widgets that fit within your system. They're all very interested. So today's market, I think, is very accepting of what they want to know is, does it work? Can it work for them? That sort of thing.
Yeah, it's just, can it work for them?
Yeah.
And I think in a lot of the high volume industries, they felt it hasn't worked for them. We're getting a lot of inbound inquiries from auto manufacturers about how they can leverage, particularly metal additive. These intricate cooling systems that really drive performance of our engines and their cars, they're interested in how we can help them work to design their products. So come back to that disconnect. But people are interested. I think a lot of manufacturers are starting to say, yeah, we should take a look at what it can do for us, but just don't know how to get started.
And I think to that point, GE has the Brilliant Factory initiative, but broadly across the landscape, I think you're seeing a lot of manufacturers start innovation centers or innovation groups, and I actually think now is the time that they've been more open than any other time to trying out new technologies. And many manufacturers or industrial companies have corporate mandates all the way up from the CEO to actually try to find new technologies that they can adopt up and down the manufacturing process.
A wise professor from Wales once said to me, the companies are different than people who run them. And so if you sit back and think about that, and you think about the various people that you interact with in a company, that's where the flashpoints come. You will find some pattern makers whose whole lifeblood is interrupted by large-scale additive. They have a very difficult time accepting what this means, some of them, and because it is classic disruption. And then on the other hand, you'll find some companies that are simply rooting for the whole industry to move forward, whatever the industry is, whether it's dental or whether it is aviation parts or whether it is a whole vehicle. And so, again, companies are different than the sum of the people that make them up.
Mm-hmm. And when you look at the startups that are working in this space, how do they usually categorize themselves? Are they focusing on a specific industry? In the case of Loco Motors, you're focusing on autos specifically. Or do they focus on a technology that could potentially be applied to a broader category of industries? And which approach have you found to be more successful, more likely to get bigger?
I think focus is something that we preach to our early stage startups. It's not necessarily that you build your technology or your product specifically catered towards a vertical or an industry, but certainly understanding where key pain points are in specific markets, what the real value proposition and the key applications are, is important. And so while you might have a technology that's broadly applicable, understanding where the need is most acute is something that we really try and have our entrepreneurs focus on and initially go to market in maybe one vertical, acknowledging that there is a broader applicability for their solution.
Yes, and? Because I think the folks who are making machines, they're making machines and they'll sell them into any industry that wants the machine, right? Then I think the and part is, if I go back to Fast Radius's initial value proposition is a virtual warehouse. Why store any, spare parts? Just let's get them to you on time. And so they're going after being able to do that. Xometry, which is a company that we're invested in, is going after the problem of how can you find additional suppliers by creating that digital overlay on those mom and pop shops. that have some capability. So I think it's understanding what the problem is and then targeting it, but focus is important.
I'm going to try also to and onto that one. Without blowing your mind, if you start to look around in targeted areas, we've hit fast radius, then you start looking at material companies. Yeah, they're the big guys, but then they're the small ones. And they are looking at sizing on composites. They are looking at metal powder. They are looking at control systems with regards to how to direct light and electromagnetic forces. You have people that are getting into directly the way in which the simulation software works,
Yep.
and they are way better than some of the traditional companies that are out there. You have other companies that are looking into volumetric math so that you can simply say, when I say it's a circle, damn it, and don't come back to me and tell me that I need it to be some sort of parametric shape to define exactly what a circle is. You have scanning companies right now that are taking the traditional CMM industries to task, and they're totally necessary because you need to validate the size of a part when it comes out. You have inspection companies that are around which basically say, all right, if the biggest blocker in an industry is the fact that I can't know whether the part is spec'd, those companies are going to be big winners when they're coming along to be able to do it. Of course, there's the machine companies that are out there. And then there is the visualization companies that say, I need to be able to see what's going on in a part, and using AR, or really in that case, it's very much VR, to be able to get in and see and inspect what's going on in the part. And then all of the supply chain associated with how to make these things work. Xometry is a great example in how to do that. I mean, it just explodes where entrepreneurs are getting into this. Again, big blue arrows going up. And there are so many areas to get involved.
Yeah, manufacturing is a system, and you can impact different nodes in that system, and all of them will give you dramatic improvement.
Well, Jay and Arden, you both kind of mentioned that this year is sort of a watershed moment. This is a tipping point, right? Where do we go from here? You know, what are the specific sort of challenges that these startups are going to have to overcome, and what is the next milestone that you're looking for?
It's a big question. If we knew exactly what we were looking for, we'd be investing in that and making a lot of money off it. But I think, you know, from our perspective, there's a couple of things that we're interested in. Broad trends that we look at within the manufacturing space. There is, how do we increase the efficiency of operations as they currently stand? So whether that's shortening up the supply chain or getting greater transparency into logistics and delivery. And then there's a complete, you know, step change in how the process is actually run, which is, you know, suppose you're an Amazon and, you know, you want to start delivering personalized, customized products. How do you do that? What is the technology that's going to enable that kind of mass customization for each individual to get a product that is relevant to them? Technologies that enable that is something that we're looking at, on top of just optimizing the current manufacturing value chain as it stands.
For me right now, I like this year, and I may feel differently about it next year, but this year, I like the customer space and going back upward from there. So find a need, because there's plenty of suppliers out there in their early instantiation. Like if you're to look out as an analyst, let's say, not an investor and not a practitioner, but as an industry analyst, finding the need and then picking off the suppliers or the companies that can develop against that need. There's a whole garden of them out there. And so, you know, that was done early on with basically Invisalign. You could have dreamed up that business and then said, the technology's there, boom, I'm gonna make it happen. There are so many industries right now where that is the possibility. And so I think identifying those customer needs gives you the early ability to get into business right now, and tying technologies together. Again, the theme is don't be afraid to collaborate, because you can't do it all yourself.
For me, I'm tending to look at a lot of things that'll help us be more flexible in our manufacturing. It's funny, Jay and I worked on a project, First Build, when we had an aviation business that built a microfactory, actually here in Tennessee.
In Kentucky.
Oh, in Kentucky,
Yeah,
okay.
right, yeah.
I'm from, you know, Chicago.
Close enough.
Close
Right on the
enough.
border.
I was close enough. And when I went down to see it, I went to the head of our supply chain and said, well, you know, we're doing it in appliances, but why can't we have factories that could make everything? Instead of, I've got a factory for my aviation, a factory for my gas turbines, a factory for my wind turbines. Why can't they do? He's like, that'll never work. But I think it can with the right technologies. And so that's what I'm trying to invest around. And we're starting to do more of those multimodal factories at GE now. So that's one area. And I think the other area is 3D printing is great. It's come a long way. It has a long way yet to go, actually. Not everybody is going to get an RCAM, a concept laser, an EOS machine, and be able to produce a part. That's good. Even within GE, not everybody's going to be able to take those machines and produce a part. It's almost like a black art getting them to work. So there's a lot of work to be done to stabilize those machines, to develop control systems, new materials. So we're investing around that as well. I love the logistics space. We've got a big, like every company, we're trying to reduce inventory. So anything that helps me just in time, we're trying to do.
I think it also, as you look at some of these technologies, there's an opportunity to inform higher up in the chain how you actually think about and design products.
Yeah.
3D printing is just one of many great examples, which is if you know that you're going to be building up something as opposed to carving out something, that changes how you design. And there's ways to create materials and products that are just as strong, that are a lot more lightweight, reduce material costs, and so I think that that's another interesting thing that we're looking at, that kind of loop hasn't been closed yet, and there's a huge opportunity there.
Well, Karen, earlier you had mentioned that we still have a long while to go to get to sort of massive manufacturing in 3D printing. Can you talk about sort of the specific technical challenges involved to get to that point, to massive 3D printing?
We're still pushing on the speed. I think we're still pushing on the breadth of materials that you can use. I think, for example, on the polymer side, I think carbon is doing a great job there. On the metal side, I think desktop metals has some interesting approaches, but just the material palette is still pretty constrained. And I think the control systems need to improve, laser power, those types of things.
It's all about getting the cost per part down.
Yeah.
That's what it's all about. And so every single bit of the equation that you can refine to get the cost per part down, that's kind of what we're looking at right now.
When you're talking about the machines themselves, right now, the cost per part is too high, or that?
Yeah, I mean, it's as a result of the speed, which they can't just print fast enough to build envelopes, so you can't build enough at a time unless you have like a massive just warehouse of 3D printers. So it's the cost of the materials that you actually use in the printer. As some of these things start to approach the right kind of metric, you get to a point where the cost per part is roughly equivalent to the cost per part of mass production. And that's when you start to see these things really start to get out there in the wild and influence the broader ecosystem.
I mean, let's be careful. It is, again, spikes that come around in different places. Don't totally despair that is still unobtainium. We've crossed that threshold this year with what we do in automotive. So specifically because of the complexity of parts, it's actually not just the same, it's a lot cheaper for us to make the whole system using large-scale additive. It's a specific industry, it's a specific use case, but we have crossed that threshold to be able to do it. A lot of work went into it. It doesn't mean that you can just hit the button and go make an airplane wing. And so that's
and I think that's true, and we just need to have more of those use cases
across
and
verticals.
that cross
That's right.
that. I mean, we've crossed that with some components in our engines.
And we didn't cross it for weight, which is interesting. We cost it for time of assembly and cost, but weight is still ceteris paribus, and so now we can focus on weight and bring it down, whereas weight savings is something that is still good in other places in additive, but we had to cross it, but we left one, attitude behind where it's just simply equal, and that was good enough for us.
We're running low on time, so I have one big picture question for you. Let's envision, let's say 10 years into the future. What does a factory in, I'm just going to pick aerospace, look like? Apply all those technologies we just talked about. Where do we want it?
First, since you got some of those.
There will still be people there. I do want to say that. There will be people. You will certainly see a lot of 3D printers. You'll probably see a lot of robots as well. Some of those people will be wearing heads-up display for AR, helping them to assemble different models of engines.
I would agree with that. I think we've spoken at length about additive manufacturing. I think Karen's point to flexibility is going to be a big one. I think we're going to not have just a rigid kind of assembly line in whether it's aerospace or other industries. I think you'll see factories that are multimodal, you can change the layout quickly. You have robots collaborating with humans, not sitting alone in massive cells. You have people leveraging AR, leveraging VR, leveraging real-time analytics on the floor. I think it's a long ways away, but I think there's a lot of promise.
Will it be as big and require as much money?
I mean, I'll give you two thoughts. One is that we've been working with Airbus for the last year, and you're going to see that factory in the near future. And so you'll get a chance to look at it on the way there. The other thing that I would say is on June 15th, we are launching an online co-creation initiative with Hewlett-Packard, which will design the factory for Mars. And so basically, when you look at it, how do you make a factory that makes the things that you need to do, which is a version of aerospace, but it is actually how do you get the factory into an environment where it's very difficult to take things. And so it's a logical use case, print the things that are going to print the things that make things. So on June 15th, you'll see that. It will be focused on how do you do housing, how do you do vehicles, how do you do water, how do you do terraforming, and a host of other initiatives. And so you'll get to see that factory develop online.
So in 10 years, we'll be having this discussion on Mars.
If Elon Musk can get us there.
But you'll build the factories.
That's right.
Well, thank you all so much. I think this is a really great discussion. I mean, I think we're out of time for questions, unfortunately, but if you guys want to catch them after the panel, I'm sure they'll be around. Thank you guys for listening. I hope it was helpful.
Thanks.
Thanks, guys. Wow, what a